Thanks, Monique. Thanks very much. Morning, everyone. I hope this is going to work. Hi, everyone. As you've obviously heard from Ol, that plasticizers play a key role in PVC products, particularly in the medical industry, because of mainly the properties that they impart to the products that are manufactured, whether it be the strength, the resilience in reverting back to its original shape, or the softness or the flexibility that the plasticizer imparts. Sorry, I'm just trying to move on to the next slide. Yeah, just some of the more critical medical applications where we find PVC products. Obviously, there's the general ones, gloves, sheeting, beds that are covered in sorry, I'm just trying to move around this PowerPoint in this format. So, but the more critical ones are the likes of the blood bags that are referred to, IV tubing, tubing for hemodialysis or nutrition feeding tubes, that type of thing. These are the very critical ones. Traditionally, as also mentioned, the phthalate plasticizers were used in a lot of these applications, and that was the product of choice, particularly DHP. And but because this is such a widely used plasticizer, it's also became extensively scrutinized and tested, which has resulted in ongoing tightening of regulations regarding its use and restrictions of its use. Due to this regulation and restriction on DHP, many of the high human contact applications, like in the medical industry, have moved away from the low molecular weight phthalates, DBP and DHP, to more suitable alternatives, which could be your higher molecular weight phthalates like DINP or DIDP, or to other phthalate-free plasticizers, DOTP or DINCH. So in these applications, we really don't find DHP plasticizer as a plasticizer anymore. However, in the more critical ones, applications, particularly in the medical devices, it's a little bit harder to move away from the traditional DHP plasticizers. And this is largely because of some of the new unique properties that it brings to these products. For instance, the blood bags, where the period that the blood can be stored in the blood bags is considerably longer with DHP. Or for instance, if you take a breathing tube or an IV tube, the softness of a breathing tube, if that's permanently in a patient's mouth, or in an IV tube, for instance, if that gets kinked when the patient is moving, some plasticizers may not allow the PVC product to revert back to its original form. And you may then, obviously, this could be life-threatening in that whatever fluid is passing through that tube may not be able to flow easily. This is also sometimes can be a problem with other polymers or plastics that are used for these types of devices. Particularly when it comes to blood bags, there are significant benefits of using the likes of DHP, and this is mainly due to the lipophilic nature of DHP, which actually leaches out of the PVC blood bag into the blood, and in actual fact incorporates or moves into the lipid layer around to the red blood cells. And this is why we're able to store blood for up to 49 days in this type of blood bag. it also increases the survival rate of the red blood cells and assists in the actual maintenance of the structure of the red blood cells. It also is a very easy way of enabling the blood to be worked with. It's quite a strong bag, so it doesn't break easily, as all mentioned, like with the glass containers that used to be used. It also obviously prevents bacterial infection. It also means that things like centrifugation or steam sterilization is easy enough because this is a very strong bag for the blood to be contained in. In addition to this, the likes of plasma doesn't break down when it's stored in a PVC bulk blood bag made with DHP plasticizer. And in terms of platelets, this is another complication, is that platelets require gas permeability to survive, and DHP or PVC products made with DHP have the permeability which allows ATP regeneration while it's being stored. So the actual life of the platelets and the storage of the platelets is maintained. So you can see that all the components of the blood are able to survive in the blood bag. The current regulatory status, however, as all referred to, is at the moment, or quite a while ago, it was raised as a substance of very high concern. It was classified largely based on information from animals, because it was difficult to get information from humans in terms of its toxicity. But this resulted in some restrictions in its use, although despite other products moving away from DHP, a lot of medical devices were exempt from this restriction. However, the chemical agency in Europe launched once it was labeled as an endocrine disruptor, launched a investigation into, a study to determine, and public hearings to determine whether it actually was necessary for medical devices to be exempt. This showed that the positive benefits of DHP actually far outweighed the risks in a lot of cases. The classification was inconsistent and often inconclusive. The other indication was that the daily tolerance levels are often based on a long-term exposure to a product. In other words, being exposed to this on a daily basis every day of your life, whereas medical devices, the exposure is not like that. It's more short-term, and that from this they ascertained that the highest risk individuals were babies because of their mass, that obviously the smaller mass would be exposed to much higher levels, and also adults who were undergoing ongoing treatment like hemodialysis. Now, the problem is that the toxicity profiles of the other alternate plasticizers are not that well studied and known, so therefore there's incomplete data. So, case of better the devil you know than the devil you don't. Also, clinical long-term data is not available. It often takes a long time to establish these, and there's obviously a risk versus benefit trade-off. So alternate plasticizers need to demonstrate, when it comes to medical devices, that there's no loss in clinical performance, that there's no loss in product safety or quality, that current storage, for instance, particularly with blood, is maintained, that their safety profile is acceptable, and that they obviously have a superior or at least equal risk to benefit ratio. And this is something that's been quite difficult to do because a lot of the processes and procedures are not that well in place to be able to do this and to study the alternatives effectively. Also takes a long period of time. So the European Pharmacopoeia has identified plasticizers, and a lot of work's been done in identifying some plasticizers, and some of the applications have definitely moved to these alternatives, whether they be the likes of DOTP or DINCH, the terephthalate and the hydrated product, or to other products like TOTM, which is a trimelitate. In all of these cases, the leaching, which is the moving of the plasticizer into the blood to preserve the blood, is less than DHP. Sorry, I'm just going to go back. Is less than DHP. The toxicity on all of them is generally better than DHP, which is obviously the main reason for changing. However, you can't change with a loss in performance. And in all cases, the red blood cell storage period is less than what it was with DHP. For instance, TOTM is less than half, which is not really acceptable. If you think of collecting blood, and already the blood drives that are in place to collect blood donations, if we had to double that, that would be quite difficult. So in terms of plasticizer alternatives, there is a lack of adequate data, whether it be for leaching or toxicity in many cases. Most of them are carcinogenic potential risks, ultimately, or the metabolites would ultimately perhaps have some human reproductive effects. But the bottom line is that none of them have really been studied adequately, or that it's possible. It's a very difficult thing to study. I mean, we just have to look at the current scenario with a vaccine that's been developed and the reluctance of people to perhaps take the vaccine for COVID because it hasn't been tested that long. There's a lot of reluctance and a lot of resistance to change, particularly with something that you know works so well, and the fact that it can obviously impact or have there's cost of life at the end of it. And as I've indicated, the shelf life is a critical thing, particularly when it comes to blood bags, because it would lead to increased wastage and more blood donations. So as a result, any medical device, the medical device regulation is that there needs to be a justification for the continued use of DHP. This was brought in I think, July 2019, and it's got to be appropriately labeled if there is the justification to continue using DHP in a device. The path forward in terms of trying to move forward with some of these devices that haven't been able to be moved away from DHP is that the Scientific Committee for Health and New Emerging Risks adopted a guidelines for a benefit risk assessment of phthalates and the use of them in certain medical devices. And the purpose of this was to make sure that all aspects in the evaluation process are considered. So you don't just look at perhaps an alternate plasticizer, but maybe a completely alternate material. This has been tried, for instance, in blood bags where they've looked at using an alternate plastic and you don't get the storage period of the blood, or completely different designs or treatments to be able to do away with a device that is made with DHP. The guidelines factor in a process for a benefit risk assessment that at the end of the day would come out with an outcome as to whether it needs to be authorized, the use of DHP in that device, or whether an alternative is available and the product needs to be redesigned or manufactured or without DHP. Also, the type of risk characterization is considered. So the path forward, the path forward is essentially that medical devices containing DHP, as I've indicated, need to undergo authorization in Europe to be placed on the market in Europe. The latest date set for authorization is in Q1, Q2 2022, with essentially the sunset date for the use of DHP being around Q3, Q4 2023. So by 2024, it's likely that any medical devices containing DHP will have to be authorized or withdrawn from the market. So in other words, an application has to be made to allow the continued use of DHP based on the benefit risk assessment, or that product has to be withdrawn. There's also from July this year, it's been introduced in Europe that any new products that are brought to market where the electrical or electronic equipment and medical devices contains DHP will be restricted. So existing products on the market can be continued, but any new development, any new product that's brought onto the market cannot be made where the cabling or the electrical work on the device incorporates DHP. So I think, as Ol indicated, there's a lot of movement away from this, and this also then has the downstream implications when it comes to recycling a lot of this material, is that it becomes more difficult to recycle if it does have DHP in it, particularly when it's high human contact applications. But at the end of the day, I just wanted to finish off with this, saying that at the end of the day, anything is a balancing act of risk versus reward. And we need to balance this with the increasing pressures on that we're facing from an environmental point of view, technology developments. We need to always weigh up whether we're not doing away with something, and that there's pure science and facts behind the decisions that we're making. And I think the perfect example of this has been the likes of the COVID vaccine and the strategies that have been followed during COVID. You've got to weigh up the risk to life versus the decisions that are made and developments in technology. And I think this goes both ways, with both the lockdowns that we've experienced and the impact that that's had on our economies and things like that, versus, again, the very rapid way the vaccine's been developed and the benefit that that's brought to the world. Even though there are risks associated with it, at the end of the day, the net gain is much greater. Thank you very much.